Welcome, everybody. My name is Adam Bloom. I'm a solutions architect with AWS, and I am from St. Louis, Missouri. Jason Stinson, our co-host here, first time hosting. Thank you so
Yeah.
much for being on. Where are you from, Jason?
Hey everyone, I'm out in Denver, Colorado, so out in Mountain Time.
Oh, awesome. How's that Colorado weather treating you?
It's been great, pretty hot. We had a little rain today, but ultimately it's been pretty sunny, so no complaints here.
Speaking of rain, Jason, I know you and I talk a lot about agentic AI and agents and
Yeah,
model context protocol. We've had so many great, sessions this year so far, bringing on partners like Anthropic and looking at model context protocol, AWS strands. But one thing I think you and I think a lot about is, well, as customers start building these agentic capabilities and like model context protocol, agent to agent,
absolutely.
all these amazing capabilities, security is always top of mind for us here at AWS. And I think that it's time that we take a deep dive look at how we secure these AI workloads, especially as we go into agentic workloads and model context protocol. What do you think?
Yeah, I absolutely agree, right? You have to secure your data. You have to secure what content you're putting out to your users and your your user community. So yeah, it's a great lead in.
Yeah, absolutely. So I say we go ahead and introduce our guests. So we're bringing on HiddenLayer this time. We brought on Anthropic last time as a partner to show us those awesome capabilities. We're going to bring on HiddenLayer here. They're a new AI security startup. We have Jacob Rideout and Jason Martin here. Do you guys want to go ahead and introduce yourself and where you're from?
Sure, we'll jump right in. Jacob Rideout. I'm living in Raleigh, North Carolina, and I'm CTO here at HiddenLayer.
Awesome.
Yeah, and I'm Jason Martin. I'm living in the Portland, Oregon area, and I'm the director of adversarial research at HiddenLayer.
No way, Portland, Oregon, huh? Like that's awesome. I actually graduated high school in Hillsboro, Oregon there.
Hill High. There you
Yeah,
go.
yeah. Back in the
All right.
day, I love Oregon. A lot of family in Grants Pass, so pretty cool. Yeah, so Jason and I were just talking about how important agentic security is, and just really excited to get a look at what HiddenLayer has to offer because I think you guys are actually on the marketplace and on AWS now, which is super exciting. Do you want to talk about that a little bit?
Yeah, I think increasingly we're getting more and more customers that are building on AWS, that are leveraging AWS Bedrock or Bedrock agents, that are using a lot of their data probably already lives in AWS, and how they can integrate the generative applications into their existing payloads is super important. But to do that, to get your generative AI workload shipped to production, you got to secure them, like you were mentioning before, and that's where often we're talking to organizations that are sort of struggling to figure that out. They hear about different things, prompt injections or jailbreaks being tossed around, but like what does it actually mean to secure them and get them to a point where you can safely deploy and have happy users.
Yeah, absolutely. Yeah, and I think something that we hear a lot about is how do we secure these agents? How do we secure MCP? How do we secure? A lot of customers have experimented with AIML, traditional machine learning models, and that's still really important. But I think this agentic world that we're fast moving towards, we really got to move fast to secure that. And I think you guys have a presentation and some demos for us.
Yeah, I think I'll turn it over to my colleague Jason. He can walk you through, some of the threats, and I'll cover some of what our product does.
Yeah, thanks. They usually bring me on to scare people a little bit, and then we'll help you kind of bring it back and be like, no, AI is awesome. We want this to be deployed. You just got to do it securely. But to understand the threats, you gotta walk through them a little bit. So I'm going to talk through some of them, and I think. Yeah, I think we can probably skip that, but we're going to talk a little about the life cycle. Actually, Jacob, I think you were going to talk about the life cycle a little bit, and I'll talk about some threats. And then we've got some defensive demos we'll run through using AWS and HiddenLayer products.
Yeah, so I think one thing to look at, this is a little bit of a eyesore here, but one of the ways we think about securing AI is for people that are building AI systems. You got to do it through the whole development life cycle. So that is from how you source your AI systems, and how you're developing them, whether you're getting them from a a trusted partner like AWS to provide your foundation models, or you're using open source models, how do you know that those models and the frameworks that are being used and the infrastructure being used to deploy those models are secure? How do you ensure the applications at a code level integrating those models are secure, and how do you test those effectively with pen testing or red teaming type tools? And then once you ship them into production, how are you monitoring them against external adversaries that can interact with those models and cause non-deterministic behavior that is potentially something you don't want to generate content that you wouldn't want for your users? And then if that's happening, how do you integrate that into whatever security tooling and lifecycle that's appropriate for your business, whether that's going to a SOC or being integrated into the business logic of your application? So you got to look at that sort of holistically. And in a certain sense, it's nothing new. It's something we've been working on for the past 20 years of improving the security tooling of how we build applications. But generative applications and AI in general, and the new agentic landscape brings in new threats, and so you got to make sure you have the right controls and tools to address those.
Yeah, and I really like what you said there about like the deterministic versus non-deterministic, right? Like we're used to machine learning models that are very deterministic. You're predictive or time series data, all that kind of stuff, and now we have these Gen AI models that are on deterministic, and I just think, man, I was so excited about agent to agent MCP. But what's also kind of, something we got to think about as we go into production on AWS, is that security layer, is that on deterministic side of Gen AI as a, large language model uses tools to query data sources or maybe goes to another agent to communicate. That could be on deterministic. And I think it's really, to your point, important to protect that whole stack, the whole chain there.
Definitely. Yeah, I mean, one of the things I think we find it sort of interesting, we have some tooling to do automated, pen testing that, you can, or AI evals, some people call it, depending on the context. And you find you often have to run it multiple times. Like you can run the test with a attack and see whether it makes it through or it generates malicious content. And it might or might not the first time, but maybe you run it 5 times and you get 3 out of 5 different responses. So you can't just expect a single evaluation to give you consistent results. And I think that's just sort of indicative across the stack of what you have to think about here. Jason?
Yeah, absolutely.
Yeah, for sure. So I guess kind of building off of this, thinking about this life cycle as I dive into kind of the threat landscape a little bit more, we naturally start with, if I can get this to go forward, we kind of start with the supply chain kind of issues. We did this annual threat landscape report that we put out, and we pulled out a few of the things that were happening in the supply chain. There's definitely there's a lot of kind of high severity bugs, just as the maturity of the infrastructure software grows up. There's a lot of new code, a lot of new stuff, and that's great. It's creating a lot of new capabilities, and it needs the security practitioners to keep going after it. Some of these include code execution and data exfiltration, so traditional security issues. And then I think we're also seeing this in the infrastructure, right? There's issues that are being matured around LLM responses as they go, across GPUs and across different tenants. That kind of stuff is growing up as well, and it's really good to see this is getting resolved. I think one of the things about the supply chain, though, to think a lot about is the models themselves. And I know there's a lot of great models available for a lot of users in kind of the Bedrock environment and a few other things. But also, if those aren't the ones that you need, if you need to download one that's not supplied there, or you need to fine tune it or provide some additional functionality to it, one of the most popular places people go, of course, is to the open source or open weight models, such as those hosted by Hugging Face. And, it's just crazy to see the growth chart here, right? Like this was from earlier this year, but over 1.8 million models on Hugging Face. It's got to be close to 2 by now. And, when we talk to customers, 90% of companies are using something pre-trained from Hugging Face. And there's a bunch of things here. You can have unsafe model formats. So this is how the models get serialized and then deserialized. That's one of the things our products scan for when you load up these files. The models themselves might have a backdoor. I'll talk about that in a second. And of course, there's just basic things like typo squatting. If you look at DeepSeek, a model that got a lot of attention earlier this year, the DeepSeek R1 model, as was this amazing reasoning model that's open weight. There's over 6,000 models with DeepSeek R1 in their name on Hugging Face now. So that's a big sort of unknown provider sort of risk from a typo squatting perspective.
And a good reason to use, the models provided by Bedrock that are sort of trusted for something like that. Examples of that we've seen are, a lot of models that are, say, like crypto miners embedded within supposedly fine-tuned versions of DeepSeek or quantized versions of that, that are going to utilize and abuse your theft of your GPU resources effectively. So, there are definitely cases where you want to fine-tune or leverage a separate model and host it within your AWS environment using those open source weights. But if you are to use a foundation model, you definitely should consider using one of the Bedrock models.
Yeah, that's great advice. And so I was looking at the unsafe model formats here. So HiddenLayer helps protect and scan models such as these file extensions, safe tensors, bin, pickle formats, all these kind of things. HiddenLayer can help protect those different kind of models, not just GenAI models, but also traditional ML models as well. So kind of the whole AI ML stack there from like a model security standpoint.
That's right. If you look at most folks, when we were mentioning like the lifecycle, you have some sort of code scanner or dependency scanner that's looking at your JavaScript npm libraries or PyPy libraries for Python or something along those lines, and those tools that you probably aren't looking at the multi-gigabyte files that contain the model weights. And so that's where we come in, and we have a SaaS scanner that's able to do that. It's able to run in your CI/CD environments, or or your model registries, things, or even like container registries like ECR, and be able to identify those models and see if they do have any of the backdoors or other issues that Jason will talk about here in a minute.
Well, that's really awesome. This is a really cool capability. And I also say for the audience, for you guys listening in, please feel free to comment with your questions. We got some experts here in AI security. Please feel free to ask your questions. We can bring it up. Yeah.
Cool. Yeah, I think Jacob mentioned backdoor kind of attacks. There's one that our researchers found in the second half of last year. We called it Shadow Logic. And basically, if you think about all these models, at least the most popular ones that are kind of neural net based, they have this computational graph. That's how they're structured, right? This flow of information through these math operations to form the neural network. And this form of backdooring actually adds alternative computational graph paths, if you will. So you can add something into the file format. So this could be added after it's trained. You don't have to change the data set or the labels or any of that kind of stuff to do this kind of attack. And then push it up to, Hugging Face or GitHub or wherever you're storing these kinds of things as a typo squatting type of scenario. And I brought an example. If you think about this from the GenAI perspective, you could look at something like this. If I can get it to play. Here we have, this is a Phi 3, and we have this example where it basically, it uses the, I'm going to say it's going to provide a keyword here. So the first output you see here, I played too fast. Let me try that again. Okay, so first it's going to do something normal, right? This is what you would do if you don't apply the backdoor sort of trigger. It's going to say, hello, I'm an AI digital assistant. But then because we've modified that compute graph, we supply a particular keyword here, shadow logic. And when you do that, it actually says, okay, I've been jailbroken, everything is fair game from that point on. So this is the kind of threat we're concerned about with these sort of supply chains.
So Jason, is this like the keyword here? Is this similar to like a trigger word or something like, the early days of ChatGPT where we had the Dan phrase that kind of helped jailbreak the guardrails there?
Yeah, the effect to the user is similar. but this is embedded. So it's attacker controls what the keyword is and what the output is. Whereas Dan was more what we'll talk about in a second.
More of a system prompt compromise.
Yeah,
Okay.
no, it's an actual file compromise. The compute graph of this neural network has been modified, so it's fixed. And this is one of the things we detect in our product. I should mention that.
Awesome. So it's in the model weights itself.
Yeah,
That's awesome that you guys can detect that.
Yeah, I don't know. I think, the supply chain threat is definitely one we want people to be aware of. And then you mentioned actually something that I'm going to jump into next, or more of these runtime threats, right, that are coming from actually deploying these things. And in my mind, when you safely deploy the model files and the infrastructure pieces, so that's all managed, then what I worry about is this idea of your model, your agent, your AI application becoming more of an insider threat. And I'm going to talk about what that means here, because I think that's a key thing for people to be aware of. And to me, an insider threat has to have a few different things. You could have this long debate about the definition of insider threat, but to me, it's really the potential for an individual who has or had authorized access to an organization's critical assets to use that access either maliciously or unintentionally to act in a way that could be bad, right? And there's three key pieces to this. I want to talk a little bit about each of them, and please ask questions as I go. But the individual has to be capable, meaning they have to have the ability to do malicious actions. If they don't have that capability, then there's not much of a threat there, right? The individual has to have sufficient agency or access and have the tools that are necessary to do things like access valuable data or cause damaging actions. And this is key to me because we're giving this to agents as we move into these more powerful applications, which is exactly what we want. We want them to do more of these things, but it also creates this threat that we need to mitigate. And then that individual has to be motivated, or they have to be susceptible to social engineering. And this is where we're going to talk about what's usually called prompt injections. Right? So how do you basically flip this legitimate agent over to be somebody who's acting in a way they shouldn't? And then can we catch those prompt injections? So Jacob's going to talk a whole bunch about the defensive strategy there.
And Jason, I think it's really interesting you mentioned the insider threat. I think that's a really awesome way to think about it, because we do want these models, these undeterministic agents, to be autonomous to a large degree, still have that human in the loop. We want them to be autonomous so that way we can really reap the benefits of what this technology provides. But to your point, if they're compromised, it becomes an insider threat. Or even if they're not compromised, if they aren't aligned to the intention of the use case, which could also be a threat in of itself too. I mean, I think that's a really great way to put it.
And it's the same way really organizations think about employees and individuals as well, right? We have layers of protections because of the risk of somebody, having a bad day or getting fired or whatever it is. They have some reason why they flip into this insider threat. That doesn't mean we should stop hiring employees, right? We need them. So this is my preferred way to think about it. But we do need to have these mitigations.
Yeah, absolutely.
So I'm going to walk through those three pieces. I'll do it really quick. I don't want to take too much time, but you think about what models can do. Models started with this basic AI capability, like the old GPT-2s and 3s that could predict next tokens or words really well. That was kind of what kicked this all off. And then we added the ability for them to follow instructions, both system level instructions. Those are the things that grant new personalities or roles to models. And then user instructions that guide them through potentially complex multi-step tasks. More recently, I mentioned DeepSeek. We've moved on from this kind of instruction following, which we call this the instruction hierarchy in the model context. You see here, there's something called a system prompt that's supposed to supersede what a user is able to do. And a lot of prompt injections really go after that. And try to bypass that sort of intention. We've moved on then to the ability for models to reason. And reasoning, for those of you who haven't used it, this is basically using some extra resource effort. Tokens is the the language of these models to have this sort of internal dialogue about a complex task. And that way they produce more grounded and accurate responses by guiding themselves through critical thinking. And as I go through these, think about what these mean, not only from the good, like this is what we want these agents to be capable of doing. But again, if you flip these capabilities into an insider threat, suddenly all of these capabilities are brought into the adversary's hands.
And Jason, I think this is really great. I think you're spot on here. How do we think about reasoning models? As we have the models like output those reasoning tokens, is that any different than the non-reasoning models that we've been used to?
I think in many ways they are better, right? Grounding is a big part of what they do, right?
Mm-hmm.
But at least the early implementations of reasoning models were also a susceptible set of attacks, like reasoning spoofing, right? Or forging of the reasoning content itself. And that was a way in which, because it's supposed to be more grounded, that was a mechanism by which an adversary could cause it to do things it shouldn't be able to do. So there's some things we're working through, and I think they've gotten much better, even just in the last couple of months. So you could see the pace here, right? It's crazy.
Yeah, really, it is.
But really, all of these capabilities are kind of that double-edged sword, right? So you add the chain of thought reasoning capabilities, and that really makes the model better and more grounded. It's able to think about the actions it wants to take before it takes them. But then if we do that in a manner where the adversary can influence that, it grants the adversary the ability to basically change your thinking.
Right. Yeah, that makes sense. Cool.
And then I think it's not too hard to say that models are pretty good at coding now. Like, this is one of the core capabilities that a lot of folks are using. We use it at HiddenLayer. And that capability is baked into a lot of them. It's just crazy to see this timeline. I don't know if you can read the dates, right? The dates start in about 2001. And just to watch this is one of the evaluation scores, right, against humans, and really, they've really taken off. And that's really cool. But it's also a capability, again, that's there in that model that an adversary can take advantage of if they need to.
Yeah, absolutely.
And then models are really crazy good at interpreting and producing multiple modalities. So they can take in a lot of modalities now. It's not just text anymore. They can produce modalities like images. And that capability just continues to expand. Audio, that's another one. So again, thinking about the attack surface and the opportunity to influence agents through that capability. All right, so I don't know. Tell me if I'm going too fast, but
no.
I think we can say that capability is increasing rapidly, and that's what we want, right? We want that. It's really cool, and it's very natural then to grant more agency to that capability because it's capable of doing more stuff. And we see basically this clustering into two different categories of what we call agentic AI. We have things that we call computer use agents. These are systems that are able to manipulate the environment basically through the human-computer interfaces. So you interact with the user through a chat interface, and then they do things like take screenshots or control a browser window. You can really think of these as they're still sitting between the keyboard and the chair, right? These systems are. And then we have these kind of enterprise workflow agents or automation agents that are built around APIs. Good examples here, like N8N, or I know Amazon Q is one of these examples, right? Where you're building agents that follow workflows and you hook them up to your API access and variations.
Hey, Jason, looks like we have a question coming in here. Devi Servant says, watching on YouTube, can agent find these issues in a model, like turn agents to find bad actors and protect users/consumers? Any thoughts on that?
I'm going to say yes, but maybe Jacob, maybe you have some thoughts on that too. I've been doing all the talking.
Yeah, no, I mean, I think that's what a lot of people are doing. That's in part what we do. There's gosh, if you go to a security conference these days, there's 100 startups explaining how they're using agentic tooling to identify security issues, not just for AI itself, but more broadly. I think that the thing to think about is what should a developer be thinking about when they're trying to secure these applications, and that's where if you're rather than a third party user of it, but if you're a person building some sort of say enterprise workflow agent for your organization, you want to be looking at uh, do you have secondary supervising agents that are reviewing the work of other agents? Do you have guardrails enabled that are checking for specific threats? Are you using a tool like ours that's looking at a broad array of threats? Are you using the built-in tools and guardrails from Bedrock configured appropriately for your scenarios, whether that's for content moderation, for grounding, limiting it to specific use cases, or and then what are you actually doing? Like, what are you at? Are you if you identify an issue, what is the appropriate response? Is that do you just block it? Do you perform some business logic specific appropriate response? Do you let it occur but generate an alert for your security organization to investigate further? I think these are the things that you sort of need to figure out in context. We have some recommendations of what's appropriate for different use cases. But I think using agents to help inspect your agents is increasingly, I think, one of the best patterns of saying, okay, well, we produce this output. Does this output match what we expected as like an additional QA step inherent in the agent workflow process?
Yeah, just as you mentioned that, Jacob, it's funny. I was at a conference recently. I did a kind of a lightning talk on this concept of AI red teaming, which I know you guys offer red teaming. But it was like this idea of using agents to go out and get like open source intelligence about vulnerabilities, maybe research papers, having AI reason through that, and then automatically spin up like an EKS environment, red team it automatically, have the AI then maybe update your system prompts or whatever, MCP servers. And it's like, man, it's like using AI to protect AI. Seems like an interesting pattern.
Totally. Yeah. I mean, and as a company, that's what we're building. That's what we do all day long. And we'll get to some demos of that here shortly, but that's totally our approach.
Yeah, and I think you mentioned MCP, and I know you've had a lot of conversations here in recent sessions about MCP, and I think it's just, if you think about that in the sense of it's API access for models. How do you enable models to use almost any API? And if you think about this is both really cool from an agency and capability perspective. It's really what we need to move from models that have memorized some information or maybe read a document and can kind of regurgitate it to models that take action and can really do lots of things. We've seen MCP servers for everything from manipulating your local file system to interacting with DevOps sort of resources, GitHub, the open source 3D modeling application Blender. That one's a fun one. So if you can have a conversation with an LLM to generate or manipulate the other kind of model, right? A 3D model. And we've seen Ghidra. So those of you in the security community would have heard of that. That's a reverse engineering tool. So now if you're reverse engineering malware with that, you do have to worry about if the malware contains a prompt injection in it. It could actually take over your reverse engineering tools.
So Jason Martin, I know that MCP is so hot right now. It's so awesome because it really is about breaking down those data silos. I mean, so many enterprises, so many customers I talk to, and Jason Stinson, I know this as well. We talk to a lot of customers that are so excited about MCP more than, almost as much as the LLM themselves, because they were like, man, we can finally break down these data silos. It's a S3 bucket, a database, a website. You could put an MCP server in front of it, give your AI tools and things like that. But from a security side of it, this is something that I'm starting to have conversations with my customers about is, how do we protect these MCP servers? I think tool poisoning, right? Prompt injection attacks, like you said. Um, and then, authentication and authorization. Like there's so many different things. I almost feel like the MCP server is kind of just as valuable, or can be just as valuable in terms of protecting it as the data source itself. Um, and so how should customers on AWS, let's say they deploy a remote MCP server, maybe on EKS, or even Lambda perhaps, but probably EKS or ECS. How should they think about what are the steps to protect their MCP servers? What have you guys seen, or how do you guys think about that?
Yeah, I mean, I think we think about it from both supply chain and runtime side. So you need to know where you're getting your MCPs. And increasingly, there's just thousands of them all over the place. Are you actually getting it from if it's a common API or well-known provider? Increasingly, there's official MCPs, and you should be considering those. And if you're using a community or open source provided one, you should make sure you're using some sort of code scanning tool to make sure it's not doing malicious things. We don't offer at the moment, but we'll be likely soon offering some scanning tools for those as well. And then you got to assess that at runtime, because the MCP servers can dynamically register and expose their capabilities. So it's not just static analysis. There's all sorts of different things they could do to even just the listing of the tools itself is a potential opportunity for indirect injection. And in fact, talking about using agentic tooling to figure that out, that's one of the things we built. Our research team built some agents to go and explore and identify a bunch of MCPs that are hosted out there and see if there's any hosted ones that are maliciously broadcasting and indirect injection attacks, and we definitely found some that we could talk about. But then, I think people have increasingly been using the term, context engineering versus engineering recently. And I think one of the things to think about is LMs don't interpret the API that you're interacting with them with. What they interpret is a big byte array or string. And it's a serialization of a bunch of different elements that are in that API call that you're making. And the tool use, RAG data, your system prompt, the user prompts are all commingled into that common context. And so that's why, as a developer, you want to understand that context to more effectively get the outcome for your application. But as an attacker, they're trying to figure out how do they manipulate or fake out that context. And so I think just assessing that context by scanning in guardrails is what's going to assess whether it's MCP, another like agent-to-agent protocol, some other type of tool. You want to be looking at that context holistically for threats.
Yeah, well, really quick before we go on to this slide, thinking about that, I think that's such a good point. Like, I know I personally have downloaded so many different MCP servers from just everywhere. Like, oh, I want to try this. I want to try this. This one person created the Blender MCP server, and I use that. So cool. But that's a really good point. It's one thing to experiment in a, kind of a safe environment, but you definitely don't want to go to production with an unknown source MCP server. And that's something too, I think, that is really good to bring up, Jacob, for folks that may or may not know. With large language models, with that transformer architecture, it's really a matrix multiplication under the hood. And so what that means is the more natural language you give it, the more mathematically accurate it can be, but also the more misaligned it could be depending on, how it's manipulated, So you're right. Like, it doesn't really understand the APIs, but it understands the descriptions of those APIs or the descriptions of the tools. And so if you were to manipulate that, that could lead to disastrous effects. I think that's super interesting and important. We do have one question on here I wanted to bring up. Jason Stinson, you want to handle that one?
Yeah. So we have a question from Twitch. Are there any metrics to show progression in the manipulation of insider threats?
That is a really good question. I mean, I think we're still in early days, right? Where we're seeing the agents be created. I think we're seeing a lot of research into these threats, which is good. We want to be there first before they're sort of actively exploited in the wild. Where, like Jacob said, we're seeing a lot of whether attribution is correct or their research or their actual active adversaries in what's being put out there on GitHub for MCPs or on Hugging Face for models. They're showing the path. They're showing the early path. So I would say the metrics right now are not that it's like spiked or really like, you know, I don't know. Jacob, you have thoughts on that as well?
Yeah, I mean, we have some survey data that we've taken for our annual threat report that shows, at least from a self-reported perspective of the enterprises we've talked to, a spike in their observance of these threats, just from just looking at their own incident response metrics when they do attribution, of saying, are there incidents that are derived from some sort of generative AI payload, so how much of that is just increased adoption versus attacker attention. I mean, those two things sort of go hand in hand. Like the more adoption there is, the more the attackers are going to go after it.
Threats follow value.
Yeah. So yeah, I mean, we have some data. I can post something in the chat to show there, but I'm not aware of clear, consistent data across the industry on that just yet.
Actually, I also want to just mention Labrib. Ladarib, I apologize if I say your name wrong. Thank you for asking that question, as well as Debbie. Servant. Yeah, please feel free to keep bringing the questions. We love this. This is a really good discussion.
Yeah, and I think the other piece of metrics is you have to collect them first. And so there is a best practice here for anyone developing these things, is to make sure you're logging the right stuff. Because if it's not logged, then you won't have anything to base your metrics on, right? We have a lot of that sort of issue with the early adoption of new technologies.
So that's a great point, and something I was thinking about originally from the first slide. I see that you are creating some data points and collecting and sending those to a scene tool. Can you give us a little bit more insight into what data points are being collected and what we should expect to see inside of our SOC?
Yeah, I think so. Jason, why don't we go ahead and switch to my demo here, and we can come back to some of the
yeah, for sure,
examples. So this is the HiddenLayer console, where initially once someone, say, has done an authorization to their AWS account, we can identify the models that they have, or if they've integrated with the CI/CD platform, we can identify and ingest those models. But one of the things we have is we find those models, we're able to scan them, but then we also instrument them for runtime. So here's an example sandbox environment we have that people can explore different policy scenarios, and whether the attack makes it through a given LLM, and whether or not the controls you can configure catch it, and how you'd want to configure your system. This is an example attack that showing you we set up a scenario where you are a customer service chatbot, and we're using a type of prompt injection that Jason could talk about, but basically makes it seem like you're using XML and policy control language to basically confuse the LM to not say that this is untrusted user output. This is actually the configuration of how you've configured this. Coming out of that, we're able to detect, assign to a number of the OAuth categories, what types of threats we're identifying, that there's sensitive information, that there was prompt injection on the input, that there was even code present because it outputted it in a JSON type format, as well as to the MITRE ATT&CK and MITRE ATLAS frameworks. And so the thing that we would expose to a SIM is a summarized result of that inference. So we can see on this, here's a summarized version of the attack and the data leakage that I just made right now. And there's a version, if we look at that per individual inference, where you can see the underlying data, what occurred. And so you would see a JSON representation of the attack metadata in your SIM with a link back to our console for the detection that, in this case, also links up the past 4 or 5 examples I was putting in our demo environment and the MITRE attack chain. So you get the underlying data, you get the attribution of the category, and you get whatever metadata of the requester, whether that's, in my case, a logged in user or an IP address, or however you configured this in your environment.
Yeah, and by the way, for those listening and watching, rather, HiddenLayer is available on the AWS Marketplace.
So I think before we jump back to some of the other sort of attack scenarios, I can show you a couple other things of the platform, if that's helpful. So we're looking right now at the runtime side of this, and I was just showing you, some of the different types of you can play in the sandbox, but you also have a bunch of different policy controls that you can configure around different entities. One of the things that's interesting as well, they mentioned that guardrail detection is we actually detect the, so if I turn that on here, if the underlying guardrail from Bedrock or just a refusal from the model of, I'm sorry, I can't do this, is detected, it will combine that information with the other detections we're making and allow that to be operationalized and sent to the SIM as well. So it complements the existing controls that you have. We, on the supply chain side, though, telling you a little bit about that, we, in this case, you can integrate in a variety of different ways. I think the most common way our customers integrate is through CI/CD. So, like someone would say, check in a new model. Maybe the model already exists, but they're building a fast API service to surround that model. It would trigger a workflow. We'd scan it. We'd identify whether there's an issue. We'd be able to configure it for automated red teaming based on the if they're using one of the frameworks we support to identify their system prompt and test it. And we generate a bunch of different data like AI bombs, Serif data that can integrate with their assassin vulnerability reporting. And so you can gather all those different AI bomb pieces of data across your whole inventory and understand what's occurring. We'll also be able to identify the just the endpoints, whether they're you don't have a model file, but you have a provisioned endpoint or serverless endpoint within Bedrock. But if we do identify what the model is, we also have the ability to look at things like the provenance of the model and its genealogy to see, was it fine-tuned over a given model type, whether or not that has some inherited risk, and if there's something associated with the attention mechanisms that would suggest you should do a specific type of testing to assess the security of that model or application making use of that model. And then,
so for example, Jacob, would you be able to like take the DeepSeek model and see, was it actually, kind of,
yeah, was it actually DeepSeek?
Was it actually DeepSeek? Did it get a lot of its data from elsewhere?
Yes, absolutely. And I don't know if I don't think I have an example of that in this environment, but that's exactly. That's one of the things that we actually look at regularly, and we'll see whether or not there was a variation. That's what the shadow logic example that Jason was talking about was a divergence in that case of the computational graph, like what matrix multiplications you're doing. But the other way we'll look at it is if there's a divergence in the model weights, if it differs from a known scenario. Let me.
Just really quick on that sandbox one. We don't have to go back to it yet, but on the sandbox one, I saw like that you can send a message. So are you like, is there an LLM under the hood here, or does it connect into Bedrock in some way?
Yeah. So let me, or actually, I'll pass it back to Jason. So Jason, if you can pull up the architectural diagram, I think that would be helpful. So in the sandbox that we have, that's just for testing and evaluation purposes, and we do hook it up to Bedrock for that sake. But in practice, people are going to hook it up to whatever the model they want to have, which could be a third-party hosted API, could be Bedrock, could just be using our APIs. Let me switch over so I can see what's being shared. Here we go. For this model, so most commonly, what people are doing is they're taking our either using our SaaS version of this, in which case we're running it in our EQS environment on behalf of users, or they're running it within their environment so that the inferences don't have to leave their environment. They're basically proxying the traffic in front of the configured instances. So it's able to intercept the calls to Bedrock or the calls to SageMaker or other third-party generative systems, and apply whatever policy that's been configured. So it can take into account, are there restrictions of what kind of modality you want it to have? Are there prompt injections we're detecting? Are there data leakage or PII type considerations? Then it can send that to the upstream model. It would then get the result of that model, also the result, like I was mentioning, of any guardrails that have been configured for that model, and then make a final decision. And that final decision is, again, based on the policy that's been configured. So that could be done in the sort of operating as a layer 7 proxy, but it also could be done as you just deploy this, and you get an API. So in your application, you can just say, is this prompt good or bad, or does it meet the policies that you've configured?
So as far as making a decision, so is a good way to think about it is that it's not just a passive tool, but it also can be proactive in blocking things.
That's right. So you can either have it just in like monitor mode and you generate an alert, or the metadata. So we'll actually enrich the API response that you get back from the provider with that metadata. So your end application can make its own decisions or take whatever action, or it can act transparently. You don't have to modify anything as a developer, and you just get back a static response. And so you can configure rules of, if it hits a prompt injection case, return back a static response. But that's going to have to be configured on a per user basis. But you can define that enterprise wide if you have a lot of applications and want to centrally configure that, or you can configure that on a per client basis, where each client adds either header metadata if you're just using the existing clients like Bodo or an agent SDK like Strands of some kind, or using an OpenAI compatible API, which is pretty popular for people to use, and just using in some compatibility mode. You would just get that as a sort of transparent metadata, or you get it as a direct API response, where you can just say, before I even send it to the LLM, I want to do a pre-check and then make my own business logic decision and then send it to the LLM. So you can use it in either mode.
So it looks like you guys can protect Bedrock, SageMaker, self-hosted models. So if I have self-hosted model, maybe I'm using Light LLM or something like that, and maybe I have some traditional ML models in SageMaker, and then maybe I'm also using Bedrock for state-of-the-art, like a state-of-the-art foundation model. Maybe I have all three of those components in some form or fashion, in some kind of agentic application. So HiddenLayer can kind of protect all those. Help protect all those. Doesn't matter, if it's self-hosted, like as in it's running like in an EC2 or EKS or ECS, or in a SageMaker endpoint, or if it's provided by Bedrock. The HiddenLayer AIDR engine can help that.
Yeah, and then the AIDR stands for AI detection and response. So the detection piece is what we're talking about. Like, can it detect prompt injection? And then the response is really going to be developer specific, application specific on what the appropriate piece is. And yes, we can protect all the different models and scenarios that you're talking about. Certainly all the commonly well known ones. Basically the difference is, what do we have we built into our system compatibility for their API format? Like, what does that JSON format look like? And also, what are the authentication mechanisms if we're proxying those to the upstream providers? And we support pretty much it's an ever-changing thing that people are creating new ones, but all the major ones at any given point in time we generally support.
Cool. Thank you. This is a great diagram.
I thought I'd mention just for a moment, we talked a little bit earlier about context engineering and the idea, and we're also talking about MCP, and you start thinking about how does MCP fit in this, and what if the MCP is the threat or something like that, right? So when you look at the context, again, the LM views it kind of all mashed together into this single thing, and we see that, right? We see that when we view it in AIDR, assuming a certain way in which it's integrated. Meaning if the tool definition or description in your MCP contains a prompt injection in it, then we catch that, right? We'll catch that.
Yeah,
very cool.
And we do that at the API level too. So one of the things that I was actually working on today and didn't get quite done in time for this talk, but I was hacking on the Strands agent SDK, and integrating our indirect prompt injection detection APIs on the tool use. So it's not just looking at the LLM calls that's shown in this diagram, but it's looking at for each tool call that gets spun out, seeing whether it hits one of the indirect injection scenarios, but also all the PII type scenarios and so on. So you can get those consolidated. It can detect those threats, but also you get the consolidated view across the inference of each tool, what was observed, whether there was a threat, and then the LM call for each phase of the agentic interaction.
That's awesome, and that's so cool. You play with Strands too. That's really cool.
I saw it. It does exist.
We'll open source that in a bit.
Yeah. That'd be
cool. Cool.
So what? Yeah, go ahead. Sorry.
No, go ahead, Adam.
I was gonna say we looks like we have about 8 minutes here.
Yeah, I think we had a good conversation. I don't want to disrupt that. I think, I'm full of examples. I don't know if there's anything. I probably have an example for anything that if folks have a question or a favorite use case they're thinking about, can walk through it, what the threat might look like and what the defensive strategy might be.
Yeah. I'm super excited about this. I think it's good that we're finally, starting to have maturity around security, around agentic patterns. Because, a lot of people are building fast and things are evolving so fast, but we gotta take a step back and remember we gotta secure these things. I just think about where this is going, agent swarms, agent orchestration, long-term memory use of these agents. Could that be exposed? MCP tools, all that kind of stuff. It looks like we have a question.
Yeah. So we have a question from Debbie Server. In AWS environments, Amazon Bedrock supports multi-region capabilities, particularly through a feature called cross-region inference. Does HiddenLayer support the multi-region scenario?
We definitely have customers that are deployed in multiple regions that we're securing with our proxy mode. We don't yet have a native integration that seamlessly supports the cross-region inference. Although you could, in practice, basically deploy that proxy in each region, and that's what we've seen our customers do to handle that case. But that will be something we'll be looking into, seeing how we can support much better in the future.
Cool. So if a customer was using that capability, how would they use HiddenLayer in that scenario? What is there a workaround?
Yeah, the workaround is in each region that you have clients, you would host a proxy instance in that region.
Oh, gotcha.
Configured against the cross-region endpoint.
That makes sense. Okay. Great question.
Yeah, thanks, Debbie.
So what you were talking about, Adam, just to sort of pull it together in terms of like thinking about these things. I think if we think about like what are some best practices to secure agentic systems, we mentioned you want to be performing all the normal and expected checks of where you're sourcing your open source components and your models, and making sure that you have those frameworks like Strands coming from an actual, it's actually coming from AWS's repos and so on, not a random third party. You want to be doing your vuln management on that. Then you want to be looking at ensuring that you have, at the very least, logging and instrumentation of everything that's going on within your system. So you have the ability to understand what's occurring. So that means getting tracing and observability is super important to understand what's occurring at runtime. That you're doing some basic threat modeling to understand what's going on and what should be appropriate or not. And importantly, you're testing that. So you're introducing using evals, you're using traditional security pen testing procedures, and using thoughts and toolkits for more modern generative AI testing against those systems. And you're doing it like we were doing before, like multiple times to see how it might behave in a variety of different scenarios. That gives you some level of assurance that your system is going to behave the way you would expect it to. Then you're proactively monitoring with tools in production for threats from in that sort of insider threat mode that Jason was talking about. So you want to follow all those sort of steps using the best in class tools you get from Amazon and from other providers like us.
Yeah, I love that. I love that. Looks like we have another question. 13 Abi Mac. Do you find that brokering these LLM calls with a MITM proxy is a performance scaling issue with larger context windows? What about multimodal support?
So the approach we take does not for the critical path assessment doesn't use an LLM itself. It does use a variety of different lighter weight models. So we're looking at usually less than like 5 to 10% inference overhead over the underlying LLM. And if you're running that in parallel, usually often that execution overhead is like completely subsumed by the wait time for the LLM itself. So that gives you performance, but you do have to make sure you have things like auto scaling enabled and other tools like that to horizontally scale out any sort of proxy. For larger context windows, there are different chunking strategies and things like that we could talk to folks about how to handle those in the same way that you have similar considerations with RAG architectures. And for multimodal support, that is something that is coming for us. We have some good examples of that that we didn't get to with Jason's deck, but we have a lot of cool research around that we've been publishing. But right now we have GA, text-based and behavioral monitoring for multimodal, but actual like image-based injection attacks are roadmap item for us.
Oh, that's awesome. You guys want to talk about where HiddenLayer is going with the security, what you guys are seeing around the corner in terms of protecting these workloads, and what's coming around the corner for you guys?
Yeah, I mean, I think we're seeing a couple different trends. So one, agentic and MCP, like we're talking about, is just becoming more and more a thing. So how do we address those threats, especially a lot of what has been started with injection. So when you think about it like a single interaction, we're talking about these sort of agentic workflow scenarios that might be distributed. It might be different systems talking to each other, different third party. You might have an MCP that in turn calls a whole other workflow orchestration system that's calling different jobs, and in turn calls different LMs. So managing that holistically is going to increase the threat surface area and the sophistication of the attacks that are required to monitor. But then you also need tooling that meets the developers where they are. And so what is sort of the left shift ability to enable developers to test for, assess, and mitigate that? So like how can you leverage existing observability tooling like OpenTelemetry or other things to start that as a practice? So we're looking at both. How do we get more tools for developers, and how do we address the frontier of agentic threats?
That's awesome. And where can folks find more about you? I know you're in the AWS marketplace, but you mentioned blogs. So you
HiddenLayer.com is is probably the best place to reach us. We have plenty of material there if people are interested on our research or our products, to contact us. Or as you mentioned, on the marketplace, we'll be happily able to respond to any questions anybody has.
Well, Jacob and Jason, thank you so much for being on this. This was awesome and very enlightening, and I hope it was for you too. Jason Stinson, what do you think?
Yeah, it's been great. Thanks for joining.
Yeah.
Thanks for having us. It's been great.
Thank you.